Here we go, guys. Test 27 practice. Let's do this thing. 1 through 4, just find each one of the following without a calculator. It's asking you on all these, like on number 1, let me blow this up a little bit. Number 1's asking you, what power would you raise 3 to get 81? Well, 3 to the 4th power is 81. The answer to a log is the exponent. If you see a log with no base, it's really base 10. It's common log. So it's asking you 10 to what power is 10,000? Because 10,000 has 4 zeros, it's 10 to the 4th power. This is asking you 8 to what power is 1? Anything to the 0 power is 1, so that's 0. And number 4, anytime you see natural log, it's base e, so it's asking you what would you raise e to get the 4th root of e. Remember, bottom is the root, top is the power. The 4th root is really e to the 1/4, which means the exponent, which is our answer, is 1/4. Number 5 and 6 are straight up, and 7 are all calculators. So number 5, I'm just going log 742 in the calc. We're going 4 decimal places. I'm getting 2.8704. And then this number 6, natural log 0.047. Punch that one in. Get a negative 3.0576. And the reason that one's negative, obviously, is because 0.047 is less than 1. And lastly, it says log base 589. To do that, we're going to change the base formula. We do log of the big number over log of the base. Punch that in exact. Or you could do natural log. It doesn't matter which one you do. Log 89. Make sure you close your parentheses around the 89. Divided by log 5. I'm getting 6.4218. And also you can check all. Well, you can check that one. You can do 5 to that power, and it should give you very close to 89. Number 8. Graph that log. Remember, logs and exponents are inverses of each other. So last week when we did exponential growth and decay, our asymptote was on the x-axis. So this week our asymptote is on the y-axis because they're inverses. Last week our first point we used was at 0, 1. This week is at 1, 0. And I just messed that up because I didn't notice that in parentheses it has a +1, which means everything's been shifted left 1, opposite of what you think, inside the parentheses. First point's 1 to the right. Second point, I want my parentheses to be the same as the base. Well, the base is 3, so to make the parentheses 3, I'm going to put a 2 in for the x. If I put a 2 in for the x, I get this. I get log base 3 of 3. That's always 1. When your base is the same as a big number, log 3, 3 is 1. Log 4, 4 is 1. So I plugged in 2, and I got 1. So there's my second point. Remember, you got to show both points there for me. Number 9. 10 and 11 also express in terms of sums and differences. So we're going to break this up as big as we can. First of all, number 9 is all multiplication. So I'm going to break that up with addition. That's an A. I just put a 3 for some reason. Break it up x to the 5th plus log base A y cubed plus log base A z. And then don't forget your exponents need to go in the front. So put in the 5 in the front of the first term, 3 in front of the second term, and there's no exponent on the z. And guys, that's all you do. You just split it up like that. Now, number 10 has got multiplication and subtract and division in it. Now, the general rule is this. Anything that is in the numerator is going to have a plus sign. It's going to be multiplication. Anything in the denominator, because it's been divided, is going to be subtraction. So I'm going to write it just like that. I'm going to say log 4 plus log b. Now the denominator is minus always. Minus log 7 minus log a squared. And the only thing I got to do there is I need to take that log a squared. I could have done this when I wrote it the first time. Probably should have to save a little space here. The exponent always needs to go in the front when you're expanding. Number 11. All kinds of stuff at number 11. Okay, so first of all, it's all big square root. So I'm going to put the 1/2 in the front first. Remember, square root. Bottom is the root, top is the power. So I'm going to have a 1/2 of natural log. Let's do this. Let's make a big bracket here of natural log x to the 6 over p5 r to the 8, like that. Which means that 1/2 is going to go for everything I do. So I'm going to have 1/2 natural log x to the 6th minus natural log p to the 5th minus natural log r to the 8th. And leave the 1/2 out there for a second. Put all these exponents in the front. X6 ln x, 5 natural log p, 8 natural log r. And then I'm going to distribute the 1/2. So 1/2 times 6 is 3. 1/2 times 5 is 5 halves. 1/2 times 8 is 4. And there you have it. All right, now numbers 12 through 14, you're doing just the opposite, going backwards. So what I'm seeing on this one, number 12, is I'm seeing subtraction, which means I can combine that into one log, which I'm trying to do by doing division. So if I do 1,000 divided by 10, I get log of 100. Now that one's actually one I know, because remember that's base 10. 10 to what power is 100? 2, because 10 squared is 100. Don't forget to do that last step when you can. Next one. First of all, I'm going to put the exponents back where they go. That's a 1/2 power. Bottom is the root, top is the power. 1/2 in the front means that's a square root of x. This is a y squared, and that's a log x to the 4th. Now remember, everything with addition, I'm going to make this one big log, but everything with addition is going to go in my numerator. The subtraction means division, which goes in my denominator. So on my numerator, I'm going to have a y squared on x. My denominator is going to have an x to the 4th. And there's 13. 14. 14's got some stuff also. So first of all, let's put the exponents in the front. This is really x to the 1/2 power. And if I put the 1/2 in the front and multiply by the 2, I just get x, which is kind of weird. So to combine them, well, let's do this first. I'm putting now that I've done that, well, let's do this. 2 natural log x minus 1 natural log x. Because they're the same, you can actually combine them and make it natural log x. Or another thing I noticed, well, I stumbled right there a second ago. If I put the exponent back on this one, it'd be natural log x squared over x. Remember, the minus sign means you can divide, which I just did. Then you can cancel the x and the x squared, make it natural log x. So either way you want to go there, works just fine. I think that's all I got on this slide. 15, 16, 17, solving equations. First of all, 15 is one of those you can actually find the same base on. So 15, I can change the 16 to a 4. 16 is really 4 squared. Once you have the same base, you can forget about the bases and set the exponents equal to each other, because if the bases are the same, the only way that can be equal is if the exponents are the same. So I'm going to move the 5 over and divide by 3, and I get 8/3. And that should solve that one. Number 16, this time I cannot find the same base. When you can't find the same base, you got to log both sides. And remember, when you do log both sides, the x goes in the front. I'm going to do natural log both sides just because it's only 2 letters instead of 3. So to finish up here, because the left-hand side says x times natural log 15, I'm going to divide both sides by natural log 15 and see what I get. I'm just going to punch it in my calculator. And again, if you want to do log log on that problem, that is fine. I'm just doing it, I guess, because I'm being lazy. It's just, a little bit quicker to write. So my solution is going to be 1.5688 on 16. 17, hang in there, we're getting close here. Got x's on both sides, and I can't find the same base on 17. That's pretty much impossible. So let's go log both sides. So I get this. This one a little bit weird. To get the x by itself here, I forgot the x over there. That's an x right there. I can't get the x by itself. So what I'm going to do is I'm going to put the x's together. So I'm going to say x natural log 28 plus 3x natural log 10. You know what? I should have used log because that's 10, but that's okay. That would have been a lot smarter on my part. To get the x, I'm going to factor out the x, which leaves me this. Leaves me natural log 28 plus 3 natural log 10 equals 0. I didn't draw my L. Okay, now, to get the x by itself, because it says x times this, I'm going to divide both sides by this big old bracket. So I'm going to do 0 divided by all of this. And here's the deal about this. If you do 0 divided by anything, you just get 0. All right, if 0's on the bottom, you can't do it. But if 0's on the numerator, you just get 0 every time. Last slide, here we go. Number 18, synthetic. We've been doing synthetic for a long time now. You should be awesome at this, just saying. So first of all, the 2's going in the box. I got a 2, a 0, a 3, a 0, and a -1. Make sure you get all the zeros in there. I'm going pretty quick here. Bring the 2 down, multiply, add, multiply, add, multiply, add, multiply. And there's that. Don't forget to write your answer. Because we started with degree 4, our answer is going to begin with degree 3. So we're going 2x cubed plus 4x squared plus 11x plus 22 plus 43 over x minus 2. 18, solve this thing. To solve this, first thing we need is a LCD. I'm going to factor this right here, make it x plus 3, x minus 3. Because, by the way, that is the LCD. That's all the factors. So I'm going to multiply every term by x plus 3, x minus 3. Every term, x plus 3, x minus 3. Every term, x plus 3, x minus 3. Now, what happens is over here, the x minus 3's cancel. That leaves me at 5 times x plus 3. The second term, the x plus 3's cancel. That leaves me 3 times x minus 3. The right-hand side, it all cancels. That leaves me a -2, which is great because when I do distributive right here, there's going to be no squares, which means no factoring, which is kind of awesome. So if I add stuff that I can, add my like terms, I'm going to get 2x. 24 is -2. Move that 24 over. It's going to be -26. Divide by 2, you're going to get -13. Check your answer. Now, all you got to do to check is make sure it doesn't make your denominator 0, and it doesn't, so we're good. Number 20, the last one, finally. Square, multiply double square. If you square 2, you give 4. If you multiply those, you get -14, but then you double it, you get -28i. Then you square the second term. Don't forget to square the 7 and the I. All right, now don't forget I squared is really -1, which makes that really -49. So I'm going to do the 4 minus 49 and get -45 minus the 28i. Guys, there you go. All right, guys, use this video as much as you need to. Do great tomorrow. Can't wait to see you make your great scores again 2 weeks in a row. See you then.